Hello students of grade 11. Today we'll do mathematical reasoning. Exercise 14.5. This is both for general maths and applied maths student. Question number 1. Show that the statement P, if x is a real number such that x is cube plus 4x is 0, then x is 0, is true. We have to first show by direct method, then method of contradiction, then method of contrapositive. So let us do first by direct method. Direct method means you will solve directly and space is less here. So let us do direct method. Okay, direct method is we'll take let x cube plus 4x equal to 0. Here x is common, we can write x squared plus 4 equal to 0. Either x equal to 0 or x squared plus 4 equal to 0. That means we're getting x equal to 0. So we can say thus P is true statement. Second is method of contradiction. Contradiction means we have to say that they said if x is 0, that means we'll consider not 0. If it is not 0, we have to show that the statement is not true. So what you'll say, let x cube plus 4x equal to 0 for every x belong to real number. Suppose x is not equal to 0, then what happened? That means x square must be greater than 1 or greater than 0. If x is not 0, the square number will be always greater than 0. Implies what? X squared plus 4 must be greater than 4. I'm adding for both sides. That means x squared plus 4 can never be equal to 0. It's greater than 4 but cannot be 0 because it's greater than 4. So now we know that x is not equal to 0 and x squared plus 4 is also not equal to 0. That means the product also will also be not equal to 0. If I multiply, x cubed plus 4x is not equal to 0, which is a contradiction. We're considering they are equal, but it's coming not equal. So which contradict? Our assumption. Therefore x must be equal to 0. Therefore P is true statement. Let's do the third method. No space I'm doing here. Method of contrapositive. So contrapositive, as we have learned in the last exercise, we take the second negation of the second statement and negation of the first statement. So we'll say let x is not equal to 0. We have to say let x is not equal to 0. That means x squared plus 4 like this is greater than 4. I'm doing directly. same like this, okay? That means x square plus 4 is not equal to 0, and the product of this and this also will be not equal to 0. So x cubed plus 4x is not equal to 0. So if the second statement is not 0, the first statement is also not 0. That means method of contrapositive. We can say that thus P is true statement. Okay. If the second statement is not true, the first statement is also not coming true. If x is not equal to 0, we're getting that this is also not equal to 0. Okay. And I'll just increase. If x is not equal to 0 implies x square is greater than 0. After that, you can write this state, then this state. Okay. Let's do question number 2. We've got that by all the three methods. Question number 1, with all the three methods, we got that the statement P, given statement P is true. Let's do question number 2. Show that the statement for any real number A and B, A square equal to B square implies A equal to B. It's not true by giving a counter example. You have to say that it's not true by giving an example. So simple example we can give. Suppose A is 2 and B is minus 2. So what is A square? Will be 2 square, that is 4, and what is B square? That is minus 2 square, that will be also 4. That means we're getting A square equal to B square. A square and B square is same. But what about A and B? But A and B are not equal, because A we're taking to B is minus 2. So therefore we can say that the given statement is not true. Here in this situation, A square and B square is same, and they're saying that A and B must be same, but we're getting that if A and B are not same also, A square and B square can be same. So therefore the statement given here is not same. Let's do question number 3. Show that the following statement is true by the method of contrapositive. So first we'll take the second statement first. The second statement here is, we'll just write Q. This statement will just take Q, and this statement will just take R, okay? Or you can say this one as Q and this one as R, no problem. So Q means X is an integer such that X square is even, and R, the second statement, is X is even. So we have to show that contrapositive and means negation of these two are implying same, okay? So we'll say, let us assume X is not even. We have to say opposite of this. Let X is not even. We have to get this one, okay? Negation of R also not even. Negation of Q also not even. So we consider let X equal to 2m plus 1. If X is not even, that means X is odd. That means 2m plus 1 is odd. Now we'll square it. 2m plus 1 whole square. If we square this, A square plus 2ab plus B square will get 4m square plus 4m plus 1. Now common here is 2. If I take 2m square plus 2m plus 1. So we're getting multiple of 2 into something plus 1. That means this is also odd. So we can say that if x is not even, x square is also not even. That means negation of R implies negation of Q. Therefore, by the method of contrapositive, we can say that, or we can say that P is true. The statement P is true. Okay. When we are taking this one as opposite, even this one become opposite. Okay. They say if x is not even, that means x square is also not even. We're getting. Okay. Let's do question number 4. By giving an counter example, show that the following statement are not true. You have to give an example, like question number 2. If all the angles of a triangle are equal, then the triangle is an obtuse angle triangle. Now, if all the angles of a triangle are equal, what we get? If angle A as per the question, angle A equal to angle B equal to angle C, what we get? We'll consider as x. If all the angles are equal to x, what do you get? If we cancel, we get x equal to 60 degree, which is not obtuse. That means the statement is false. Statement P is false, or you can say not true, anything. The equation x square minus 1 equal to 0 does not have a root lying between 0 and 2. So we'll solve it and check. X square minus 1 equal to 0. X square will be 1. So x will be plus minus root over 1. So x is plus minus 1. That means x is either 1 or minus 1. Thus any one of the, so one of the root 1 lies between 0 and 2, and they say does not lie. That means the statement P is false. Again, in this question also the statement P is not true. That means P is false. Okay, because we are getting value 1, which is between 0 and 2. Let's do question number 5, last question of this exercise. Which of the following statements are true and which are false? In each case, give a valid reason for saying so. So, first statement is, each radius of a circle is a chord of a circle. This is false. Why it's false? Because chord touches the two parts of the circle, but radius does not touch. Okay, so each radius of a circle is a chord is false statement. Reason is, or we can say, as per the definition, chord intersect the circle in 2 points. Okay, and the radius intersect the circle in only 1 point. Okay, the circle in 1 point. That's why it's false. Second statement, the center of a circle bisects each chord of a circle. That is also false. This can be shown by drawing a chord of a circle which is not diameter. Suppose there is a circle. They are saying the center of a circle bisect the chord. Suppose I made the chord here. How can you say the center of a circle is bisecting the chord? So that's why it is false statement. Circle is a third one. Circle is a particular case of ellipse. This is true, okay? We have not done this exercise. Ellipse. The shape of the ellipse is a little bit like that, but it can be expand. If I increase this, it form a circle, okay? That's why the statement is true. Suppose in the equation of ellipse is x square by a square plus y square by b square equal to 1. This is the equation of ellipse. If a and b are same, equal to k, that means it become equation of circle, okay? See, x square by k square plus y square by k square equal to 1. If I take the LCM, cross multiply, x square plus y square equal to k square. So this is ellipse, but if a and b are same, that means it form a circle. So this is the equation of circle. So that's why it's true. So the situation is same. Ellipse becomes circle if the value of a and b are same. That's why it's true. So circle is a particular case of ellipse. Is a particular case of an ellipse is correct, okay? The last statement, if x and y are integer, then x such that x greater than y, then minus y is less than x is true, okay? X greater than y implies minus x is less than minus y. Simple. I can give an example, or we can say that 5 is greater than 2. But if I put negative sign, which one is greater? Minus 2 is greater. So this is an example. So this is the best example. You can say that the statement is true. Now you can pause the video to write all the solution. Thank you.